So we're recording, and we're going to be doing the chapter application here today. First off, they're saying you need to get this database again. We've already had this a couple times. Let's go ahead and pull it up, just like we always do. And like we always do, make sure that you enable editing at the top, that kind of stuff. Bum, 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 ba-dum, bum, bum, right there at the top. Bloop. Okay, so now we're good to go. We can delete columns, we can do everything we normally do, but now let's actually read what they want from us in this particular case. So, finding two free cells in the spreadsheet, we need to type these two things, and then we need to put them in here. What? Like that's it? And they're saying right here that they're doing it for drive, but I'm telling you that if you go to A, the A column, what does the A column say? Drive. It's like already kind of pre-done for us. So let me follow the instructions exactly as they say. Find two free cells on the spreadsheet. There's some right there. There's some right here. There's some other ones down there, right? Do you understand what it means by free open cell? Anything, just as long as it's ready for you. Now, I can't give you the same numbers, so again, I'm going to delete a little bit. Y'all are not doing this. I'm just deleting some of mine, okay? So we get different numbers. And so I'm going to follow the same rules side by side. Here we go. So I'm just going to go to, I don't know, that one. That's a great cell for me. And it says type this average. So equals average A2 to A36. Now mine, of course, is too far. I've got to change mine, but yours will be the 36. So I'm going to do mine as 21, okay? Mine's 21. I'm going to hit enter. You'll see that I just literally typed it in. It says average, just as they said it. I just changed my number at the end, right? Enter. And then right below it, equals STDEV for standard deviation. Again, A2 to A36. I'm not doing 36, I'm doing 21 particularly. That's up to you. Well, it's not up to you. Typing that formula exactly as it with the equal sign, right? Enter. And there we go. Are y'all doing what I'm doing? Are we cool with what? Oh, I'm coming. That's exactly what. Yeah, I like it. Cool. And then yeah, the STDEV kind of thing. So I got them. Now on the Excel, I'm sorry, the chapter application, they're wanting you to type these in, and they say round to 5 decimal places. I don't have 5 decimal places here. I don't know if you do. I don't. You do? Good. Do that. I don't. So I'm a little bit lost. I'm just gonna do because that's what I have. You have something else. So that's okay. 95572. Now pause. Do I do a 2 or do I do a 3? 4 there. No, I leave it as a 2. Yep, exactly. 5 decimals, and that's wild to me, okay? Again, my numbers are going to definitely be different than your numbers. Let's just say that you don't have the exact, 5 decimals that they're looking for, and the answer is 14.9, and they got 14.8, that kind of thing. I will see that as I grade, because I have to grade all these manually, and I would add points for that, okay? So I'm not too worried about this kind of thing. Just do what you got to do. Is that okay? Keep cruising. Assuming that this variable is normally distributed, what proportion of the data would be less than 40 minutes? And then they say blah blah blah. Type this thing in. So it's basically on the third free cell. So like down here now, I'm going to type that thing, norm.dist 40, and then all this other stuff. Now, the problem here is that you're not typing. You're typing the 40. I think I've only got. What do I have? 19. I think I have 19. You have 40 different entries. Because again, mine's going from. No. Hold on. Can you like chill out for a second here? Let me see. Oh, I got 20. So I'm using 20. You're using 40. Okay. But we have to actually type those previous answers in here for the mean and the standard deviation. Okay. So I'm going to type 30.9 and then the 14.9, 557.2, and then comma true, and then close it off. Now you can see the formula better up here at the very top. You see that formula up here at the top? I know it's kind of fuzzy. I can't blow that one up. Wish I could make it bigger. But I'm just typing this whole thing in. Again, not mean. You're typing the number. Yes, a decimal. I'm coming. Oh, no. That's not cool. Okay. So I'm gonna try to show this. I'm gonna try to show this because that is the most common thing here. Is that like let's just say you're typing this thing norm.dist 40 and then you type mean and standard deviation like that and true. That won't work. They need the numbers in there, not those words. And so yeah, that's the most common thing that happens. Yeah, yes, to the 5 decimal places. That's good. Yes. The 40? I'm sorry. Oh, yes. Oh, not 40 values? Oh, well then, yeah, I guess you're right. I guess I'm going to have to do 40. Wow, thank you. I didn't see that. Thank you. I'm coming. Thank you. Yeah, that was me being dumb. I needed to read. Shouldn't I have read a little bit more? It looks really good. Just go with the very front and that's good. No, you're doing great. Cool. And then the next one you type is the norm.dist, all that kind of stuff. Yes, very good. So yeah, you're right. 40 is part of the question. Cool. So yeah, I'm gonna hit enter and yeah, wow, big difference, big change. 40 because it says less than or equal to 40 minutes. The 40 means the 40 minutes they're asking about. Yeah, not the. Now y'all said you had 35 entries. I guess they already took care of that. So. Well, there you go. Anyways, so it says, what's your answer? And did they say how many 3 decimal places? Okay, so why is mine not like a number? There we go. So then 0.729. Why is mine not typing? 729. There you go. For mine. Yours is different. know. Okay, good. Good. Okay, let's see what else we got. Question 3. Now determine the actual proportion, 40 minutes. Oh, there it is, 35 data points. Okay, good job, guys. Good job. So they say figure it out, find the actual proportion, sort the drive, and count them. Okay, this is going to be interesting. You ready? I'm going to change it up a little bit, okay? So I'm going to delete all these other things here. Like anything besides the drive, I just think it's going to get in the way. It's going to ask questions. It's going to say, you really want to blah, blah, and you're going to be like, no, or yes, and it's all over the place. I'm deleting everything else besides drive right now so that we get a little bit of room. Okay. Now, this says to sort this, which it already looks sorted. It already looks sorted. Why am I deleting something if it's already sorted? I don't know. Anyways, I was going to data sort, and it would have done it for me, and everything would have been fine. But oh my gosh, I feel silly again. Twice. So how about this? Let's start over. You don't need to delete anything because it's already been sorted for you. Isn't that true? Yay! So you're looking right here, and you're going to count how many are actually less than 40. So here we go. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. And I'm going to even highlight this to make sure. If I go here, I can say count is 15. 15. Okie dokie so far? Okay, cool. So I got 15, but out of what? Again, out of the total of, for you, it's 35. For me, it's not. So I'm gonna just have to do the math. I'm gonna use Excel because it's super cool. I'm gonna do the 15 divided by the 20 that I have. Hello. But you're gonna be doing the 15 divided by the 30. Okay. I can't give you that number, but you can do that, and you can do it in Desmos or on the side in your calculator, whatever it is. Again, I'm not going to hit enter on this, but essentially you're doing the 15 because everyone's got 15 divided by the 35, and then you're going to get an answer. And I can't give you that answer, but you can have that answer. It's only an enter button away, but I can't show you. Is that okay? Not okay. I'm coming to you. I'm here for you. All right. Can't hit enter. No way. That would be cheating. Okay, how does your predicted probability from number 2 compare with what you got in number 3? Is there a difference? Blah, 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 blah. So I had 72.9, and then I had 75. So mine's pretty close. Probability calculations are different. In 2, we calculated this, and blah, 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 blah. Would not be very, okay. The probabilities are the same. I don't think they're the same. They're very close. And then the probabilities are different. That means there's something wrong with our technology. Is there something wrong with Excel? Yes. I'm just joking. There's nothing wrong with Excel. You're going to click this one probably, okay? I mean, unless you actually got, the same exact number. Did you get the exact same number? I'm sorry, say that again. I can't hear you. Yeah. Anyways, and that's the end of the story. Wow, can we go home now? I'm just joking. We're not. Got other things. But this is fun, though. We're doing great. I can go back and re-go over this again, okay? So number 1, we found those 2 numbers. We type them in 5 decimal places. There you go. Number 2, I actually type this whole thing in, and I get a number, and I type it in. Number 3, I actually do 15 divided by, and then you get that number, okay? And then probably the number is The letter is A. Just guessing. You can hit submit. Ready? That was it. You know I come though, all right. Well, if there's nothing else to do here, I'm going to hit submit. And let's see how bad I fail. You ready? Here we go. Submit. Oh, yeah. And no, I don't want to have that. And yeah. Ooh. That's pretty bad, isn't it? Ouch. Are y'all submitting and getting better than me? Did you pass? Is it green? Okay, good. Yes, good. Okay, well mine was bad. Okay, I don't want to view my submission. It's really bad. So I'm gonna just X out of that. All right, cool. Any last questions before we move on into the rest of the lecture? Y'all are wanting to leave already. No. We have to stay up so we can keep going. Get ready for that chapter 9 stuff eventually. Okay. Good? Yes? Do you want me to come over there one more time? I'm fine with that. Okay. Good. Here we go. We're going to move on. Confidence intervals. And we already did this a little bit. I want to do a recap on it, and then we'll do the GeoGebra side every time, because that's the point here, is that we're going to do GeoGebra all the time. So just a real quick recap on confidence intervals, okay? We did this last time, but here we go. Basically, I want to give you a number, some kind of thing that I'm hypothesizing or maybe figuring out. I'm going to say 50% of Americans are female. Right, that's an awesome number, but then it might not be 50%. It might be a little bit of a range in there. I don't really know. And so instead of saying 50%, I'm going to go a little bit on each side. I'm going to be a little bit of safe. I'm going to say somewhere between 45 and 55% of Americans are female. Okay, I'm giving you a range. I'm giving you a confidence interval. And then within this range, I'm saying that I'm 95% confident in my answer. But let's explore for a second different confidence levels. Let's say that I was only 90% confident. Yeah, I want to be 90% confident about my answer. Would that make my bell curve bigger or smaller? Would it make the area that I'm looking at bigger or smaller? It would make it smaller because it's now 90 instead of 95. If this was 95, right, that whole thing, like all of this here, that's 95. Then when I go back and say, oh, never mind, I just meant 90. See how I'm cutting it off a little bit? But at the same time, my answers will be closer together. Okay? What if I wanted a different bell curve? What if I wanted to be only 50% confident? 50% confident. So, like, think about this for a second. I'm going to give you a statement. I'm going to say average, we got a, what is it? The percentage of America, what did I always say? 50% of Americans are female. So then I'm going to say 49 to 51% of Americans are female, something like that. And I'm 50% confident in it. 50% confident. Does that sound confident to you? I mean, let me get a coin out right quick and see if I'm right or wrong. That's not great. You know what I mean? So we're looking for a little. It's just no good. But what if we go the other way? What if I want to be 99% confident? So here is the 95, and then I'm going to now do 99. Woo. But you see how it's more spread out? So now I've got to say it's somewhere between 40% and 60% of Americans are female. I'm 99% sure about that. What if I wanted to keep going? What if I wanted to say that I'm 90, 90, 90, 99.99, 90, 90, 99% confident in something? I'm going to tell you this one. This is a great statement. Here we go. I'm 99.9999999 confident in that 0% to 100% of Americans are female. There it is. Did you see that? 0% to 100%. I am nearly 100% confident in my answer. I just popped my collar, by the way. You didn't see that. But anyways, I feel so good about that statement, right? But see how it's useless? Wasn't that a useless statement? It didn't help me. So in the end, blah, 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 we're trying to find happy middle ground. We're wanting to say I'm very confident, but also give a nice tight range that still makes sense to us. Cool? Okay, cool. Now, you're like, all right, Chad, are we done so we can do GeoGebra? Yeah, I know. So they go through all this cool stuff here, and yay, that looks so fun. And let's actually start doing some of this here. This is called confidence level. Remember how I was just saying a second ago, 95, 90, 50%, 99.9? That's what this is. So they're saying 92% confidence. They're saying 87% confidence. And they want to have the answers, the plus and minuses, the z equals, plus and minus some number. Where do you think I'm going to go to find this number? Where would I find a z-score like this? GeoGebra! Exactly. Back in algebra class, everyone would scream Desmos, but we don't do that here. So GeoGebra, geogebra.org. Okay, awesome. So this is your z-score, I don't know, table, your bell curve. And the reason why is because we're using 0 and 1. It's my default. Remember how we were doing that last time on the homework? It said z equals blah, blah, blah. Go back to the default. Reset it completely. And so we're looking for 90, what was it, 92? 92% between? It's not working. What do I do? We've encountered this problem before, right? And so how about this? Let's just try to guess. What if I put a 2 and a 2? Is that about 92? Getting closer. Does this seem right? Should we be guessing like this? No, what are we doing then? If I don't want to guess, look, 94, we're getting better. What's an easier way to do this? How about, instead of trying to hit the middle, what if we hit one of these ends? Okay? So think about it like this. It's a small math problem, but it's a fun math problem. Let's say that we have 92 here on the inside. Yes? Well, what would we have on each end individually? 4%. That's 4% and 4%, right? That would make 100% total, basically, right? And so what if I just hit this side up? What if I just said, hey, right here, I want to find this amount, 4% on the left side. So that's what I'm going to do. I'm going to say over here, on this side, 4%, 0, 4, and there we go. Was I getting pretty close to what I thought it would be? Yeah. But we don't want to guess. We don't get to get an exact answer here. 175. So it's negative 1.75. It's not really negative because it's a plus or minus. Either side, they're symmetric. So this is negative 1.75. This is positive 1.75. Either way. So again, that's what I did. I changed to this left side and put in the 0.04. Yeah? Okay. It's just, again, kind of manipulating what we got. Let's do another one. So it says 87. This one scares me. So I've got 87 in the middle. What would I have for both of them on the outside? 13% for both, right? For both. But then I want just one, an individual. So then what would this be all by himself? Yeah, 6.5 exactly. I'm going to tell you why I did that. If I would have told you, I mean, well, you're a smart guy. But let's just say I would have asked, hey, I got 87. What would I have on one side? That's a little bit harder to do real quick, right? I'd have to think about it for a minute. This one here, that made more sense, right? I already kind of see there's 8 missing, 4 and 4, clean cut. But this guy here, I want to make sure I get it correctly. So 6.5 is what I'm going to use. 6.5. 1.51. 1.51. There we go. Cool. Okay. Awesome. And so they can give us any kind of confidence level, and we can do that. Oh, I love this down here. Okay. Cool. Cool. Okay. So far, so good. Any questions? We're good? Okay. Y'all were thinking we're going to get out early or something. That's what it was. That's why y'all were kind of like, eh. No? What were the expectations today? So this table down here is a very cool table, and it's not as it's important. It's very important. I would say you have to memorize it, kind of, but you can always go back and use GeoGebra as well. So you don't have to memorize anything. But this is super helpful and super fast to be able to learn. That's a lot to learn, Chad. I don't think I could do that. Well, that's the thing. You don't need to do all that. You don't need any of that. You need this. So when it says 95, it's the 1.96. When they say 99, it means the 2.576. Now I'm going to prove one of those to you, at least. 95. Let's go to the 95. I'm going to do 95. But I can't do 95 right here, can I? It's not what I'm looking for. Remember, 95 is in the middle. 5% both. So what would each have? Exactly, 2.5, 2.5%. And look, it came up exactly what they have, 1.96. Okay, so that's what's connected to 95% confidence interval. 99. So again, let's just try and understand this here. I got 99 in the middle. So what do I have for both of them on the outside? Yep, 1%. So then each would be what? Yes, a 0.5%. And so that's like 0.005 essentially. And so 0.005. Did I get the 2.576? See? So I teach statistics pretty much every semester. Sometimes I only teach it once a year. But if someone came up to me and said, hey, what's the confidence interval number thingies for this and that percentage, I would already know it. It's one of those memorized things that you just stick with you. So 95, 1.96, 80%, 1.28. It's just the things that you just learn over time. If I use it that much, you'll be using it that much on the homework, right? And so then you can just kind of like trigger it and get to learn it. I'm making a plea for you. Please memorize something. You'll want to in the end. Okay, I'm so sorry. We had so much energy just a few minutes ago. I was running around the room. Y'all were getting things right. I was getting things wrong. It was great. I was being recorded doing those stupid things. All right, blah, blah, blah. You don't really need that either because from here on out, we're going to use GeoGebra for every single one of these problems. And it's a brand new look, brand new everything. I think I probably touched on it, but here we go. This is it. We're finally doing it. Okay. No, whoa, that was kind of radical there. I want this over here. I'm going to lean a little bit less. Okay, here we go. Up at the top, they have statistics. We are clicking here. And it's giving us a different kind of menu, a different kind of setup. And I'm going to be changing it to Z estimate of a mean. Z estimate of a mean. And so I'm going to go ahead and give you the preview. Here in Chapter 8, we're going to do Z estimate of a mean, T estimate of a mean, and then finally the proportion stuff. So that's like 8, 2, 8, 3, 8, 4, that kind of thing, okay? And when we move on to Chapter 9, we'll go up to here, Z test, T test, Z test for proportion. So all this stuff is for the next efforts in this class. Here we go. Z estimate of a mean. I'm going to type in everything I got. What kind of confidence level do I have? What do I put up here? 90, so 0.90. Awesome. My mean, what's my mean here? 114.00. You can see right there, there's my mean. Standard deviation. Bam. We got it. And we already did this one. And then the last one, n, is the sample size. 55. It's the 4 numbers that they have available for us. Type them all in. I don't know, hit enter or not, whatever, as long as you're getting something. And here is everything you ever needed for the rest of the class, right here. Okay. This S sub E is going to be important later, not right now. And then we got the lower and upper limits, and then they have the interval in a different setup. I doubt we're going to use that the bottom interval much, but these upper and lower limits are exactly what we want. This is the lower, this is the upper, and then we're going to just write it in there, and you're done. 109.76, 118.24, and we're done. Next question. That was it. And I didn't even read the problem, and it's okay. Sometimes that's okay. That's why I was thinking it was okay for the chapter application. Yeah, I know. Okay. Cool. Are we good with that? So these are dollars, and they're saying that they're 90% confident that all the refrigerator repair costs in all of America is somewhere between 109 and 118 on average. So the average for American refrigerator repair costs is somewhere within that zone, given that I already looked at 55 of them. And I'm only 90% confident. Cool? 90% confident is pretty good. Let's keep cruising. Oh, there we go. Interpret. So with 90% confidence, it could be said that blah, 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 for the population mean. Again, think of it like this. I have 55 refrigerators, and I'm supposed to figure out what's going on for all of America. Good luck there. But I mean, I can do it. I can just do it within a range, right? Saying, I'm pretty sure that it'll work here. I'm 90% confident. Good. Next one. Were they wanting us to do it all by hand here? Well, now he looks angry. Moving on. All right. A random sample of 54 200-meter swims has this and that confidence interval. Let's go. 90%. What's my mean? Yep, 3.35. Very good. Standard deviation. Boom. There it is. Now, this is a careful one. Be careful. Ah, you got it. Right here is my sample size. The 200 is just a name in a way. It's the 200-meter swim, blah, 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 right? But it's 54 people swimming. Okay, there we go. Lower and upper, and we're done. 3.334, 3.366. It said 2 decimals, but you know, I'm fighting it right here, you know. You want 2 decimals? I'll give you 3. Take it. Okay. That was it. Oh, you want to know what it means, right? Interpret. Did they have the interpret thing here? They did do. Oop. Nope, I can't interpret now. It's all gone. Okay, there we go. With confidence. Man, I feel confident. Population is between. There you go. Keywords. So they were talking about swim times, right? Swim times. And so I am 90% confident that the average swim time for all swimmers is somewhere between these two. I found it with 54 of them, but I think if I did like 1,000 of them, it would be somewhere within this zone. Just looking ahead. Oh, you're gonna hate me. All right, let's move on. No, y'all. No, this is fun. This is a fun time. Suppose we have scores on biology, normally distributed. Da, 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 da. Okay, cool. So we have a standard deviation, sample size, mean, confidence. So confidence interval 95. What's my mean? 74. Standard deviation. Sample size. 75. There we go. So it says calculate the confidence interval again. They're wanting lowers. They're wanting uppers. Well, just upper. I guess that's a singular thing. 73.09. 74.91. I had 75 different exams taken, and I found the average 74. So for all tests taken forever and ever, I'm 95% confident it's going to be somewhere between there. What if I didn't just have 75? What if I had 750? Compare my numbers, right? One more time. The lower gets bigger. The upper gets smaller. They're honing in on a particular thing here. What if I had 7,500? What if I had 75,000? What if I had 750,000? Look at what our number is going towards. Do you see your lower and your upper? Just take a, I don't know, round to one decimal place on both of them. What would you get? 74, right? 74, because I said that my average that I got from all these is 74. And so how many tests did I just do here? 750,000? That's probably more than all the tests combined ever. What I just found right here, my mean, the 74, that is the population mean. That's the population mean. That's the population mean. I already did it. It's like I put it on a census. The census tells us the true population mean because it's doing all the population, right? That's the idea. Cool, huh? I don't know. I just wanted to show off the coolness. Wow, so cool. Anyways, so following represents a sample. Oh, random sample of carbs. Something of this. Standard deviation, 95%. Do it. Using your calculator. What does that mean? Yay, GeoGebra. Bum, bum, bum. I need to make a theme song for it. Maybe we can come up together and do like a theme song, for GeoGebra. GeoGebra. All right, guys, where do I put all these numbers? Well, yeah, but where? I don't see it. Do I click? Do I double click? and that's the problem, right? It's a whole new thing. I haven't done this yet, but we kind of actually have. We kind of have. Let me get some more room on this. Yeah, the spreadsheet, exactly. So what I'm going to do is go back to the classic. I need to do spreadsheet. I need to get the heck out of here. I'm just going to go back to classic. You have that bookmarked yet? So I'm going to do spreadsheet, and here we go. Start typing it out manually. This is the perfect time for me to start singing a song to you. Do you think that you'll be doing this on your exam? No? Do you just give up? I'm just joking. There's a button to copy it over. There's a button to copy this stuff over. Right now, I'm just working with, PDF, so I can't really do anything like that. But yes, you're exactly right. There's a button for you to make like a copy paste, and this whole thing will be so much better. I'm trying so hard here, and I'm going to get it wrong. We're close. Oh, we did it. Okay, highlight all this stuff, and then one variable analysis. We've done this before, right? This is no problem. And then the sigma x. Okay, and we got some numbers. Now I'm going to tell you right now, You could take those numbers, write them down, bring it back to the other page we have, type them in, and we're done. Like, look, what are we missing up here? Well, we're missing my sample size. Well, it says n is equal to 30. Cool? But even better, GeoGebra does something cool for us. You see this little statistics thing here? You notice something that we've been using? Z-estimate of a mean. It's right there. So we have to be careful, though. I'm going to be careful. I'm going to click it, and we have to type everything in exactly as we see it. So, like, okay, let me see what we got. Confidence interval of 95. So we're good. 95. There it is. We're done. But we're not. No. We're not. What did I forget? What did I not type in? What did I circle and not type in? The standard deviation 12. And do you see how it has a place for that, right? We're right up top. At the very, very, very top, there's a place for that. This is the most, like, a forgotten thing. It's the place where you make a mistake. It's right there, okay? Because we're just, we're typing all the numbers in, 95% confident. I'm confident in my answers. Woo! Yeah! And no. Put the 12 in, hit enter, and then the numbers change. Did you see how it didn't change until I hit enter? Try to remember that when you're on exam, right? So that was a angry cat sound. Just reminding you. So in the end, it's still going to ask for the upper and the lower. Very simple. But now you see where I got it. Bum bum bum. Bum 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 bum. Close enough. There we go. Cool. So now you saw it. Are we cool with that? Yeah. Is that a good thing? Okay. Yeah. And not fall asleep in the meantime. All right. Here, hard break. Brand new stuff here. We got time? We got plenty of time to be sad. So, you know how I want to do GeoGebra for everything, but you can't do it here. I know, isn't that so bad? This is the meanest thing ever. How could you tell me this, Chad? Man, table flip and I'm walking out. I want to revise this a little bit because it looks so scary. And let me start over on that here. So n is your minimum sample size is equal to z times sigma, that's your standard deviation, and then divided by e, and then all squared. So I just got rid of that z whatever thing is going on. Okay. Oh, and look, magic number 30 just keeps on popping up. So the minimum sample size is the amount. So I want to know, what's the percentage of females in the population? 50%? Cool. Let me start asking. Let me start, going down the list. And so now, when I get to however many people, when do I call it good? When can I be 95% confident? Can I only survey 2 people and I'm good? Here we go. 50%. Look, 1 and 1. 50%. We're done. There it is. Proven true. Oh, you want 4? 1, 2, 3, 4. 50%. You want to do 6? 1, 2, 3, 4, 5, 6. I'm so sorry you're not included yet. 6. 50%. Still looking good. How many do I really have to do? You know what I mean? To actually get a real number. And that's what this is going to tell us. Okay, so let's try and go through this together. We have estimated that the standard deviation of this many SAT scores, is that a year? Or is that like an amount? Is that a year? Like of the 2016 SAT scores? Yeah, I know, right? It's so weird. Okay, so I'm going to be a little bit questionary on this one. I don't really know. But we do have standard deviation of this much. Okay, I can tell you that. Researching the average SAT score, want to know how many people you need to survey 90% confidence within 40 points. What should it be the minimum sample size? We actually have everything we need. Notice that my formula has a Z, a sigma, and an E. So let's do the things that I know. First off, let me rewrite the formula. Z times sigma all over E all squared. I don't have a Z yet. I'll look into that later. Standard deviation of what? How much is my standard deviation? 192. Awesome, awesome. Yeah, within margin of error, within 40, and then all of this is going to be squared here in a minute. But I'm still missing my Z. I still don't know what that Z is. I do know that it's supposed to be 90% confidence. Do you remember that table that I said for you to memorize earlier? Oh, you didn't memorize it yet because it's only been 15 minutes since I showed you. And we scrolled on, of course. Well, let me remind you what the answer would be. 1.645. Whoa! Let me show you, of course. I have to show you that. So if you scroll back up to that table, way back up here, right there, 90%, 1.645. Dang, he even memorized it. Over what, like the past 2 minutes when I saw it? No way, bro. I've known it forever. But you can see now why that table is helpful, because it makes it faster. Now, what if I didn't know it? And what if they use a weird number that we're not really used to, And that happens. Let me refresh this. You gonna let this happen here? Yeah. Dun dun. Nope. Dun dun dun. Okay. Wow, that's pretty terrible. All right. I want to do 90% confidence. 90 in the middle, 10% outside. So each side would have 5%. Is it possible for you to get the same answers? Yeah. Yeah, it's possible for you to get the same numbers. Or you can memorize a table, right? And the table makes it faster. You see what I'm seeing? Makes it faster. Okay, so you don't have to do it that way. The table's way easier. Now I got to get this thing done. I got to actually compute this thing. I'm going to do Desmos because it's easier, honestly, for scientific stuff. And I'm going to do the 1.645 times the 192 all over 4. Whoa. It doesn't look right, Chad. There we go. And there's my answer. I've got 62.3468. And it's supposed to be people. People that I survey. Because we're talking about the amount of exams they take. So that many exams, whatever. 62.34. Cool? But there doesn't seem something right with this. And I have to go up and read this one more time. If you don't mind, I'm going to read this one more time. Reading. I don't see it anywhere. So, big star for your notes because it's not there. And I'm going to have to tell you, you must round up. You must round up. And so in this particular case, how many people do I actually look at their test scores? 63. Because this is how I think about it. When you're doing a test and you're looking through this, 62.34. All right, so I'm going to go through 62, and then the last one, I only look through the first third of it, and then just throw out the rest. But that's not going to give me a very accurate answer. Here's another one, and this is hilarious. I'm just telling you that ahead of time. You don't have to laugh later. Say you're doing testing on soda bottles, like Pepsi bottles or Coke, because we do Coke down here. And so then you're testing how many soda bottles. So you pour one out into your mouth, of course, and you do another one, and you do another one, but your sample size is 62.34, right? So you're going to do 62, and then you got the last one, you just do a little bit, you drink a little bit, and then you cap it, put it back on the rail. There we go. Someone's going to get that later. Is that a good practice? Probably not. How about you just drink the whole thing and we're okay? We cool? Okay, that's how that works. Okay. So what about 99% confidence? Oh, now I got to do all this work again. Oh, it's so hard. That was the worst Z I've ever done. Hold on. Let's start over on that. So Z is equal to the same thing except my Z score. Why am I putting Z here? Oh, bad Chad. What's the letter supposed to be here? N. Silly Chad. It's okay. How many times have I messed up today? Go ahead and count them. Three times. Okay, I'm counting. You don't have to, but I will. I'm supposed to find a number here that correlates with 99%. Very close. Very close. 2.576. But yeah, that was very close. I would have been fine with 2.6. Yep. That came from the table. Again, you could do that all manually, but then you're all tired and sad and don't want to do it. Oh, so it's way easier just to go back to that table, or memorize. Not saying you have to, but certainly makes it easier. So 152.88 test scores, people. So what am I actually going to be looking at? 153 for sure. There we go. Okay. Cool. So notice the difference between sample sizes. If I wanted to be 90% confidence about this stuff, then I need to go survey 63. But if I wanted to be 99% confident, 153. If I wanted to be 99.9999999, just kind of depends on what I'm looking for. If I only want to be 50% confident, well, I'm not going to go look that one up. Because it's getting ridiculous now. As the level of confidence increases, what happens to the minimum sample size? We just talked about this. Give me some English. It goes up. There we go. Epic English right there. Yep. 6 letters, 2 words, 1 cause. Infinite possibility. I know, right? I'm doing a commercial now. Thank you. Okay, so it's cool. We're trying here to make it, fun. Yeah. Man, that's a lot of cool questions there. Wow. Okay, how about this? We'll just be done after these 3 little questions. What do you think? And these are sense here. Okay. So it says, out of everything else that stays the same, what if you increase the level of confidence? Again, think of this. I'm going from 90% to 99%. I'm going from a bell curve that looks like this, 90%, to now my bell curve. Let's start over. Now my bell curve looks like that, 99. Ugh. So is it narrower, wider, or no change? It's wider. See how it expanded out? It's bigger, wider? Because it's more area. It's 99%. 99. Ugh. It's bigger. Ugh. Yeah, exactly. Is that okay? We only got 2 more left. An increase in the sample size does what? So think about it like this. What if I were to survey 10 people, but then I'm going to start surveying 1,000 people? As I move from here to here, will my bell curve get smaller or bigger? Okay, maybe. Think about it for a second. What if I'm 10 people and I'm trying to be the same confidence level, right? I'm trying to say, hey, I want to be 95% confident, but I'm only surveying 10 people. Who knows what I'm going to have, right? So let's do percentages again. I'm going to say 30% all the way to 80%. Would that be the opposite? Something like that, 70% of Americans are female. I'm just making up like an example here, right? But if I surveyed 1,000, then I could definitely hone in on the amount of people, 95% still, but now I'm going to say 45 to 55% because I have a lot more to sample from. Is that okay? So does it narrow, not change, or widen? It's so weird. I'm actually talking about these numbers right here. Like if you did a number line and I had 30 and I had 70, but now I've got 45 and 55, what happened to those two? It got more narrow, right? Okay. I know. Blah, blah. I know. I'm trying to be a good teacher once in a while. An increase in the standard deviation. And so, if you remember another term for this, and I saw a lot of the other classes doing this recently, another word for this is spread, right? So I'm increasing the spread. So it went. Let's start with something more tight, and then I'm going to something a lot more loose. Okay, but I still need the same 95%. So 95% would be right here. Now 95% is like way out here. What happened to my interval? Did it get wider, narrower, or no change? It's wider. Yeah, it got spread out. And think about this also. I say 50% of Americans are female, right? But what about a standard deviation here, right? I'm just saying that's the average, but there's a standard deviation plus or minus 5% or something like that. But what if I change it not from 5 plus or minus 5? Let's say plus or minus like 15. What if it's just such a varying thing, right? Man, this is such. It's not good with like percentage of females. Hamburgers, that's a great one. So you got your Big Mac, you got your Little Mac, right? You got your Burger King, and you got your Burger Queen. You got your you got your this and your that. So what's the average size of a hamburger? Quarter pound, third pound, an eighth pound. Yeah, is it pink goop or is it like all fresh? What is it? What's the average? But there's a lot of standard deviation, isn't there? Burgers come in all kind of sizes. Yeah. So see how that spread would make it wider. I'm less confident in a way about what I can answer. Okay, good. Okay, hamburgers. We learned hamburgers. That was cool. Any questions on hamburgers? Great. And we're done. Finally. Thanks, Chad. I wanted to leave.